In last video we talked about the spinels and type of spinels and examples and one exceptional case. Now we'll check how to find out the type of spinel and quickly. So we have to learn some conditions and some important notes. Conditions. Okay. Condition number 1, if the spinel compound is A B2O4. okay, A is A2 plus and B3 plus. Okay, now we have A2 plus and B3 plus. If A and B both belongs to non-transition elements, then the compound is obviously a normal spinel. Okay, second case is if if A2 plus is non-transition metal and B atom has a system with D1 D2 D3 D4 D6 D7 D8 and D9. If B atom have a system of these systems, then the spinel is normal spinel. Okay, I told this, but how it is? Because if A is non-transition metal, okay, if A is non-transition metal, then if it is non-transition metal, then CFEC is 0, because for non-transition metal we do not count the CFEC energy. For that we consider the CFEC energy is 0. Okay, now B atom remains as B3 plus. Okay, and if it has these systems D1 D2 D3 D4 D6 D7 D8 D9, in these cases CFS is not 0, it have some value, and it have some value that is negative. So all the value that is negative, that is more stabilized than this atom. So B3 plus will try to occupy octahedral voids. For this reason we got obviously a normal spinel. Okay, now case number 3. Okay, if A2 plus, or we can say atom, is a transition element, is a transition element, or transition metal, we can say transition metal with this D1, D2, D3, D4, D6, D7, D8 and D9. Okay, this system. And B atom also transition metal, also a transition metal, but with D5, D6, sorry, D10 or D0 system. Then we'll get a inverse spinel, inverse spinel. So how it is? So if A atom, we are saying that this system, and B atom with this system. B atom means B3 plus if D5, D10 and D0. In 3 cases we'll get the CFSE energy will 0. Okay, but here A2 plus have these systems. In each cases, each cases we have some negative value, okay. So if A has negative value and B with CFS is 0, then A is the more stabilized, so it will try to occupy the octahedral void. So if it occupy the octahedral void, then half of the B will go in tetrahedral void. Then we will get the inverse spinel. Okay, another easy trick, these are the main conditions. Another easy trick is, that is, if Fe is present as Fe3 plus in the compound, then it will obviously a inverse spinel. Why I am saying this? Fe3 plus is D5 system. We don't have to check this. If there is a Fe3 plus, we'll take that inverse spinel, because Fe3 plus is a D5 system, CFSE is 0. If any transition element is there that is attached with Fe3 plus, then the compound will obviously a inverse spinel. We'll example as a Fe3O4. okay, Fe3O4 is this Fe2 plus and Fe3 plus. This is FeC, CFS is 0, and this one CFSE is negative value. So this will be a inverse spinel. Okay. Now we'll learn about another type of spinel, that is mixed spinel. Okay, what is this? In some of the in some cases we found that some portion of that system of that compound remains as normal spinel, and some portion is inverse spinel. That system is called mixed spinel. Okay, so in this case, what is this? There is no particular type of spinel is present there. There is this mixed one. There is a mixed of normal spinel and the inverse spinel. There is no particular type of spinel, but the normal spinel and inverse spinel is both are present in that system. So this is called is mixed spinel. Okay, where it is found when generally when A2 plus and B3 plus are or comparable in size, then the system will be a mixed spinel if the condition is if A2 plus and B3 plus both have same CFSE energy. So in each case you have if A2 plus and B3 plus have same CFSE energy and the ionic radius of A2 plus and B3 plus are comparable, then that case will get a mixed spinel. As an example, Mn Fe 2 whole 4, that is Mn2 plus and Fe 3 plus. Mn2 plus CFSE is 0 because this is D5 system. Fe3 plus CFSE is also 0 because it is also a D5 system. But in this case Mn2 plus are comparable with Fe3 plus. The size So this Mn2 plus is mixed spinel. There's another example is MgFe2O4. In this case also this is a mixed spinel, because Mg remains as Mg2 plus, CFS because this is a non-transition element, so CFSE is 0 and Fe3 plus is CFS is 0. But this in this case also Mg2 plus size is comparable with Fe3 plus. So in both cases these are mixed spinel. Okay, but in this case we can see that the Fe is present as Fe3 plus, but even though that this is not an inverse spinel, this is a or normal spinel, this is a mixed spinel. Both the normal and inverse spinel is present in this system. But another case is Zn Fe2O4. okay, here Zn2 plus and Fe3 plus. Zn2 plus is D10 system, CFSE is 0, D5 system, CFSE is 0. But Zn2 plus each is much smaller in size than Fe3 plus. Fe3 plus. So in this case this is not a mixed spinel. So what is this? Zn2 plus and Fe3 plus both have CFS 0. We learned in a previous video that the atom with higher charge density, that Fe3 plus has Fe3 positive charge and Zn2 plus has 2 positive charge. So these Fe3 plus have higher positive charge density, so it will try to stabilize this one with more number of surrounding atoms. So it will occupy an octahedral void where the coordination number is 6, but we know that tetrahedral void the coordination number is 4, so number of surrounding atoms is less than octahedral voids. So Fe3 plus go in octahedral void and Zn2 plus will go to the tetrahedral void. So it is a normal spinel, not a mixed spinel or an inverse spinel. This is a normal spinel. Okay, it's a normal spinel. So now we'll do a question that came in GATE 2019. Okay, so what is the question? Among the compound, which one is a normal spinel? MgFe2O4. We learned now that MgFe2O4 is a mixed spinel. MgFe2O4. Okay, now this CO Fe2O4. okay, what is this? Here it is CO2 plus and Fe3 plus. Fe3 plus means D5 system, CFSE 0. Here D7 system, CFSE is, what is this? 3, 4, 5, 6, 7. That is 0.6 into 2 plus 5 into minus 0.4, that is minus 0.8. And so this is more negative, so this one is more stable. So it will go for octahedral void, and this one will go tetrahedral void. Means half of this Fe3 plus will go tetrahedral void, and half of this Fe3 plus will go for octahedral void. But all the CO2 plus will go for in octahedral void. So it is a inverse spinel. So this is not okay. Now Zn whole 4 and CuFe2 whole 4. So CuFe2 whole 4, CuFe2 whole 4, CuFe2 whole 4 is Cu2 plus and Fe3 plus. In this case also this is CFS is 0, and this one I have D9 system. D9 system means this one CFSE will be 6 into minus 0.4 plus 3 into 0.6, so equal to minus 0.6 plus 0. It is negative and this is 0, so it is more negative. So Cu2 plus will go for octahedral void. So this it will go octahedral void, and this tetrahedral, half of the tetrahedral and octahedral. So it will also inverse spinel. So what is the, this will not. So Zn Fe2 whole 4 is a normal spinel that we count here. Zn Fe2 whole 4. Why this one? Zn2 plus Fe3 plus, but Mg Fe2 whole 4 is a mixed spinel because the size is comparable, Mg2 plus and Fe3 plus, but in this case size is not comparable. Zn2 plus is much smaller in size than Fe3 plus. So this is not a mixed spinel, this is a normal spinel. Okay, by this I am ending this topic. Thank you.